Alright, so VSEPR model helps us predicting molecular structure. It is called valence shell, electron pair, VSEPR, okay, VSEPR, valence shell, electron pair, repulsion. So what is that? Every structure, okay, let's say, I'm going to give you an example. Let's say if this is a structure CH4, the bond between carbon and hydrogen, CH4, these bonded electrons in a 3-dimension, they try to minimize the repulsion between those electron pairs. And the way they situated in a space, that when there is a repulsion between those electron pairs are minimized, that's where they get stable state. Okay? So what that means, that structure, I'm going to write in a theory, the structure around a given atom is determined by minimizing electron pair repulsion. Electron pair repulsion. So I'm going to give you one more example. Let's say for CO2. So CO2 is this one. Okay, this is the Lewis-Dot structure of CO2. Now, remember, when these bonded electrons, they try, if they situated this way, 90 degree, then what happened? There will be more repulsion between them, right? There will be more repulsion between them. They try to locate as far as they can, so they will have enough space between them. They repel between each other, right? So here they have a maximum repulsion, but in here they have, if they are at 180 degrees, then they have less repulsion, right? So the way this bond situated, it's going to be at 180, because that's where they get what? Minimizing electron pair repulsion. They are not going to situated at 90 degree. No, they are not stable. So any structure, they have, they take such shapes when they have minimum repulsion between those bond, between those electron pairs. So there are steps for electron pair repulsion. But before that, let me tell you that bonding pairs electrons and non-bonding pairs electrons, and what's the repulsion look like. Okay? Alright. So let me tell you, if there is a bonding electron pairs repulsion, bonding pair and lone pair repulsion. And lone pair repulsion. So sometimes atoms, for example, NH3, when you draw Lewis dot structure of NH3, there is a lone pair electrons and there is a bonding pair electrons. Okay? So, in here, remember we took for CO2. This is for CO2. Now in here, there is also repulsion between this lone pair and this bonding pair. Right? Because they try to locate in 3 dimensions the way they minimize the repulsion. Now lone pair repulsion. So for oxygen, and they are in for H2O. Now the lone pair repulsion, we need to talk about which one is stronger. Lone pair repulsion, bonding pair lone pair repulsion, or bonding pair repulsion. Which one is more stronger? Which one is pushing more?
Bonding pair.
No, the lone.
Lone pair.
The lone pair repulsion. Sorry. When lone pair repulsion, they are higher. Let me draw that. Lone pair repulsion, they are higher in their repulsion. So there is the first one, they are the higher one. Then this one. And then this one. Okay. So there is a repulsion happen between those pairs of electrons. Alright. But this one is the greatest amount. Then this one and this one. Now what happened when these lone pairs and they are pushing on that hydrogen bond, so they are getting closer, right? They are getting closer. Now in here they push less, but still they are getting little closer. In here they are equally pushing to that bonding pairs electrons. Alright? So there are some steps that we need to follow. So I'm going to write those steps.
Okay, so the bonding repulsion electron pair is that only when you have this, so you don't have any like lone pair on the essential atom?